All right, let me bring up the chat. No. Why are computers so bad? Okay, perfect. It's happening. All right, let me tweet for people that rely on Twitter as their calendar. Okay, boom. Done. All right, let's roll. I do need a 3090. Someone on Twitch says I need a 3090. They're absolutely correct. Okay. Do we have a question on Zoom? Have you fixed the doorbell? Yeah, I disabled the Zoom doorbell. I have 3 devices to manage this. This is the only thing that can stay logged into Zoom for some reason. Then I have Twitch chat on the iPad because otherwise Linux explodes. It's awesome. All right. Very cool. Let's roll onwards. Oh, I have a question. Is that a mechanical keyboard? It is not a mechanical keyboard. I'm not a hipster. I am actually an old person in disguise. This is a one of those Lenovo. It's like you take a laptop and you tear a keyboard out of it. That's what I use. I used this so much. I use this to play video games. I play Counter-Strike with this stupid thing. I did it so much that I now have to wear my tennis elbow brace. This isn't because of too much tennis. This is because of too much using the mouse with a finger. There's real deal. All right. So pwn.college. Today is going to be the start of something really cool. It's our first module of putting together the concepts that we've learned. So we've learned a lot of building blocks. We've learned how to reverse. We've learned how to corrupt memory, how to leak memory. Now we're gonna start building this, putting things together to build exploits. As I mentioned in the videos, this is a hard thing to teach because there's so many different situations. So we prepared a number of challenges for you to get at these situations because this is a well, we'll get to that later. Let's actually start with the state of the class. So first we have our meme highlight. Let me move myself over to some unused space. The memes were pretty good this year. This week we have some endangered canaries. I like this. I like this meme template. The text doesn't come across super cleanly. Actually, I should have made it bigger. But it's pretty good. The concepts that we discuss when we're hacking is going to be interesting. Are interesting probably to lay people. And then this is great. As the challenges get harder and harder, people are happier and happier with whatever they are able to achieve. It's good. It's always good in life to be happy with what you are achieving and to always push forward. So that'll be an awesome lesson for this week. All right. We got a lot of canaries. We tried to start you out with a lot of assistance, no canaries, no position-dependent code, and then gradually, as you've observed throughout the levels, these kind of helper things go away. By the end of the modules for this week, you'll be exploiting basically fully protected JIT compilers, which is what this meme is about. People dreading the JIT. It'll be fun. Don't worry. And then this meme format is pretty good. I don't quite get the meme. Maybe this is an age thing. I think our server crashed at some point while someone was writing up a Python script. But it's pretty good. All right. That is the meme templates. Keep those memes coming. There are memes, meme channels for ASU people, non-ASU people. I'll put the best memes on the highlight, and we'll go from there. All right. CTF report. This weekend, I think people were more busy than they were previously. Only 14 people played CTF for extra credit. That's okay. Hopefully it'll go back up. But there's a really cool concept in the Boiler CTF, which was Crypto World. There was a series of mini challenges that people were able to, just tackle one at a time. And there's a bunch of them. One team solved 12 mini challenges. One of the CSE 466 teams. So great job. That is awesome. I think that team got 8 non-mini challenge flags, if I remember correctly, which is incredible. So that is really cool to see. Essentially a new CTF team form and start getting better and better and better. It's actually the same team that snagged 12 flags last week, which is really great. All right. And of course, there is still time for, I think, 7 or 8 more percentage points of extra credit that can easily move you between letter grades, right? So it's very cool. Cool stuff. Is Connor on the chat, or is he on the Zoom? Oh yeah, Connor, are we had planned to put like flares from CTF for the CTFD instance for write-ups. Oh, the flares are there. Oh, cool. Yeah, we need to add 2 weekends of stuff. How do I see the flares? Oh, who was a flare? /user. Oh, awesome. Oh, okay. Etsy Shadow has flares. Let's just do a live. Oh, cool. Here you go. Here are your flares on CTF time. Very awesome. Very awesome. All right. Radiger. Wait, why can't I find your name? All right. For some reason, I can't search this list. Okay, cool. Moving on, let's go onwards to the scoreboard overview, since we were looking at the scoreboard. All right, so how did ASU and the world do this week? So we're baby mem. ASU snagged the top spot back. But then the 4 people afterwards, the rest of the top 5 were from around the world, non-ASU students. Someone fell back a bit because they got more sleep this week. Exactly. So this week we have, I think now 8 of the top 20 are from worldwide students from outside of ASU. 12 are ASU students, so it's very cool to see that competition continue to evolve. And obviously I am biased. I like seeing ASU on the top, but of course this is all hands off. There's no ASU last week. We had Hollow Circuit take the victory. This week 0-1. If we take my camera away, we can see that in order to get to top 20, or we're still at the place where top 19 have solved everything. There's one thing that Rent hasn't solved yet. Otherwise, all top 20 would require perfect solves. But that's an interesting thing. The inverse of that is that only 19 people in College has pushed through every single challenge, which would be cool to see more people as we have more time for makeup, be able to get that perfect score on the scoreboard. All right. Grading. So we started the course with 209 students. We have 131 still registered. Out of those, 14 have stopped doing the challenges. So I think they're just waiting for the withdraw deadline, because there's no real rush otherwise, I guess. Compared to Baby Rev, Baby Mem had fewer E's and then more B's and A's and so forth. So actually, whereas Baby Rev had everyone tended to hit a wall at C at enough points to get a C, which was the Jan 85 challenges. Here, people seem to have hit a wall at the getting enough points to get a B. The curve is tightening, so people are doing well. I'm pulling up. As I said, I will not pull these cutoffs by more than 1 percentage point per week. I'm pulling them up 1 percentage point. So last week, the cutoff for B was 78, cutoff for C was 64, cutoff for D was 50. Now it's 51, 65, 79. So we're pulling them up a bit. This is the grade without the curve. Let me get rid of myself here. There we go. This is the grade without the curve. We'd have something like 15% of the class failing. With the curve, we're down to, I think this is like 8 or 9 students, something along these lines. And we have this very nice, not so much bell curve, but a linear increase, especially when considered that A+ is basically a subset of A. So we have what ends up being a traditional College exponential rise in grades as you get higher. Again, things are someone on Twitch says D is failing. I don't actually know the requirements. I guess D probably doesn't count for your the term is C's get degrees, right? Not D's get degrees. But yeah. Let's see. Okay. Someone said on Twitch, Fradiger and one of my graduate students, actually the captain of Shellfish, created a walkthrough video, 2 different walkthrough videos on how to approach Jan 85. So I guess this is actually part of this, what to do if you're behind. So don't panic. The challenges are still worth half the points, and everyone's now staring at number 4. I'll talk about that in a sec. The challenges are still worth half points, and you can go now to YouTube. Go to playlists. There's an ASU Reacts Jan 85. There's a playlist. Oh, oops. Here we go. All right. 2 videos on this playlist. One is... wait, where's the other video? Why is this 1 out of 1? Okay, hold on. Let's back out and just look at videos. 2 different videos. I guess I fucked up the playlist. I have to add the second one. So we have one video from a student in this course and one video from a student not in this course. One of these is an hour and 15 minutes. The other one is 5.5 hours. 2 different approaches to reverse engineering Jan 85. Go take a look and if you had trouble approaching Jan 85, this will hopefully help. Awesome. Yeah, so FreakMod mentioned, I'm guessing Fradiger is FreakMod, but that's just a guess. But they mentioned on Twitch that, okay, awesome. So this video, the 1 hour 15-minute video, is made after the fact. You solved it and then went back and made the video. This one is a live attempt at solving it. If you want to see how the various, it includes various dead ends and so forth that were followed. I think Klasm, who made this video, did went through and actually put timestamps if you are interested in jumping just to specific things. So this is him reverse engineering the add instruction, for example. Okay, cool. Then what else we got? There's still CTF extra credit. This is incorrect. This is 8%. I messed up. And then I decided, so someone asked me, why is the Y grade deadline? Why was it last week? Oops. This kind of stuck with me. I made it last week because the suggestion was to make it earlier rather than later in the semester. And the semester, I think at some point someone said try to aim for October. But I realized that the first combo module is actually a great place to make the Y grade cutoff. So we're going to extend the Y grade option until next Wednesday, which is when this combo module is due. So give it a try. If you feel like you can, you need that Y grade safety net. As a reminder, a Y grade counts as a C or better. It doesn't impact your GPA, but it probably doesn't count for certain requirements. I don't know. Confirm with your academic advisors now, and then email me before the due date to switch in if you want. After that, it'll be too late. Final deadline. If you switched in and you're now regretting you want to switch out, email me before the 14th as well. Okay, awesome. Any questions on any of that? Let's actually catch up on questions in general. Someone's asking, having our semester shortened by a week, do we still get a week to make up for what we missed so far? We might get a shorter time to make up. I'll have to look into the exact schedule that's remaining. I never really counted the finals week, did I? I'll have to look into it. Okay, another question. 9% extra credit. Yeah, this is incorrect. I'm sorry, I made a typo, or I forgot to update this slide. It's 8% now is left. 8 or 7. Alright, and then people on Twitch are discussing horrific setups to allow them to use Windows to hack. Man, who uses Windows? Alright. Cool. With that, we're moving on to exploitation scenarios. This is going to be an awesome module where we'll put together everything we have learned. But first, any final questions about baby mem? Someone's asking in terms of baby mem. In general, how deterministic are malloc and mmap? In general, they're actually very deterministic, with the exception of where they're based, right? So let's take a look. All right, let's take a quick look, and we'll give kind of a half hour to this, and then wait, it's 5. It's almost 5. So we'll do. All right, we could probably even do an hour with this stuff. Okay, so let's take a quick look at mmap, right? So actually, let's do this. This is the memory map of cat, right? If you look at where, so mmap starts at some randomly chosen offset in the Linux kernel and then walks by the Linux kernel, right? The kernel chooses your base address for memory mapping, and then for whatever reason, and this changes depending on the kernel version and so forth, you start as you progressively memory map more and more pages, you just step backwards from that chosen offset. So you can see the offset that's chosen here was this 7FE9931AE000, and then progressively mapped stuff just keeps filling in behind to the left of that in memory, right? All the way back to, you know, the last one that was allocated was this stuff is 7FE92216C00. But here you can see it's from C00 to E00. Then there's another mapping from E to C, another from C, and that's now it's a different one than this C. So this is 6C00, 16C00. This is F6C00. And then from F6C00, we go to F9100. From F9100, we go to 1090, and so on, right? So we have just basically a contiguous bunch of memory. This means that if you leak out any pointer here at all, you can likely figure out where everything is. That's a weakness. There are certain academic approaches to addressing this weakness, but we don't have a good solution. Currently, if you leak a handful of addresses, generally speaking, you can tell where everything is in terms of memory mapping. Then a couple of other mapping locations. One of them is the binary. The binary has the location of the binary has nothing to do with the location of these mappings. Just completely different somewhere else, right? Usually at 5.5 or 5.6. Okay, that's the binary. Then the heap is at yet another location. It is near the binary, but I don't think that it is. It shouldn't be directly related to it. So let's grab 2 of these guys, and then we'll just give this a shot. Let's subtract the base address of the heap. This is where stuff goes when you malloc it from the base address of the binary. And there's no way, but now I'm doubting myself. So that's that. Base address of the heap. That's the base address of the binary. Yeah. Different offsets, but as you can see, they're much more similar. They both started with 55CEED. No, 55CEE, and then one is D and one is F. So there's some relation, but they're at kind of at different distances from each other. But if you look at the distance from libld to libc, it's always going to be the same. So let's do that. Here is the loader, libld, and here is libc. Okay, and obviously in hexadecimal, that ends in 000 because it's the distance between pages, and every page is 0x1000 in size. Let's take a look at the same thing over here. LD libc. See, we have to continuously stay up to date. So one thing that has changed is this. Let me make sure that I am not about to say something completely incorrect. Okay, that is 6 pages, and this this is 6. So where's the difference coming in? Is there unmapped regions? There is some unmapped regions. Okay, interesting. So it looks like there are now some unmapped regions between libc and libld. Okay, this must be libc's data. Yeah, there's some unmapped. Okay, so this must vary slightly. Could be, I'm not 100% sure. Obviously, I didn't keep up for a split second, and something changed in the security posture of mappings. No. Where does the difference come from? Did I just paste the wrong thing? All right, let's try this again. We're taking the base address of libld, subtracting the base address of libc. Okay, that's the 212. Let's take the base address of libld again and subtract the base address of libc. Okay, I screwed it up the first time. They are exactly equally offset. But the thing is, there's no reason why this has to be the case, right? I mean, you can map these libraries have nothing to do with each other, or they access each other in the same way that your main binary accesses the libraries in a position in an offset agnostic way, right? You could conceptually map them at completely random places in memory, and it's not. I'm sure there's a reason why Linux doesn't do it, but I don't exactly know why. So mmap is very, very predictable, except for this first address right here, or this one right here, right? If you know that address, then you can figure out exactly how mmap goes on from there. Malloc on Linux is the same way. Malloc is fully deterministic except for the location of the heap. But otherwise, if you have the same sequence of allocations and deallocations, you'll have the same offsets off of this sequence. And both of those concepts have been touched on now in BabyMem. Cool. Someone asked on Twitch, is the state-of-the-art of stack canaries really a single 8-byte value that never changes for the lifetime of the process? Sadly, yes. There is some academic work on updating the canary every time you fork or something along these lines. And there's actually no reason why we can't just go in and randomly re-randomize the canary. But probably what is holding us back from doing that is this concept that if you have an exploit that can get around the canary, you likely can get around a replacement canary as well, right? So I think optimally an approach that can go and randomize the canary at fork would be great. And again, academically, there are papers written about this and implementations of it, but they've never really been adopted. Generally speaking, we have this, and I'll get into this much more in depth when we talk about heap exploitation. But generally speaking, developers are fairly dismissive of security researchers because developers just want to build shit and make it work and have it work fast. And then as security researchers, we come along and we say, hey, wait up. We need to implement stack canaries. And a stack canary is going to add 2 memory operations, 3 memory operations, 1 write and 2 reads, 4 memory operations, 3 reads, and a write at every single function invocation, right? So you could say, okay, but you're adding all of this overhead. And a canary has measurable overhead depending on how your function is written, right? If you're just calling a function, and depending on how your program is written, if you're calling a function in a tight loop, function does nothing, then a canary is going to have significant overhead percentage-wise, right? Likewise, a lot of security in malloc and so forth has overhead. And there's this constant battle between security researchers and developers about what level of these sort of mitigations is correct. For example, I don't know if Linus still has this view, but Linus Torvalds had this view that we just shouldn't have bugs, and then we don't care about security because there are no bugs. If there are no bugs to exploit, everything is great. All right, let's see. Other discussion. Someone's asking if I'd ever try Temple OS. Maybe I'm actually running a highly themed Temple OS. Just make it look like Linux to fit in. All right. Then there are specific levels. One person said level 8. And then there is a level 11. Scrolling up in the Twitch. All right, let's take a look at a couple levels, and then we will move on. All right. People are requesting Yarn walkthroughs of Yarn 85. It's pretty good. All right, let's launch out the teaching. In the meantime, well, I guess Connor's generating all of the levels for the next homework, so we'll probably in 30-40 minutes we'll start up. One thing actually, since we're on that subject, before we get ahead of ourselves. I mentioned this briefly somewhere in some announcement. This is the first time that we tried to do this combo module, right? In the past, we explored these individual topics, and then the class ended. So we are a bit worried that it might be more difficult than expected. It's very hard, like I said, to teach how to combine these concepts through anything but practice. So what we're going to do is we're going to launch collaboration hours all week for this module. So everything that you normally do in collaboration hours, you can do it. You can chat through on stream. You can chat in the collaboration text chats and so on. Don't share code and don't share flags. But if if you're sharing your screen and someone copies your code, don't do that. But try to share concepts on screen and otherwise. The rooms will be open all week. The collaboration rooms. Don't share the flags. Then we have to start reporting you for academic dishonesty and so forth. FreakMod showed the Yan 85 flag on stream, but that's okay. The flags are unique, per student. So we'll just keep that in mind when our cheating detection system starts alarming. Okay. Cool. Let's take a look at level 8. And some of these I went through in office hours. So if there are concepts that you're missing, refer back to them. So let's launch this guy up. Cool. Let's SH in. All right. So level 8, there's no win variable, right? You have to execute the win function on your own. There is no canary. And I don't remember which one level 8 is. The win function has this check that you have to jump over, hopefully, but that's not that was introduced well before level 8. And yes, I remember. This is the thing we need to fool. Okay, so the teaching challenge, the walkthrough says, hey, the challenge is going to be careful. It'll allocate a correctly sized temporary buffer, and then it'll copy that in to the stack. All right, so I'm actually going to go a little more in depth than I did in office hours because now the assignment is over. Let's take a look at level 8 testing because it's way easier to reverse without all the prints. And I'll show you what's going on. Yeah. People on... What the heck? Why did I get logged? Oh, because I'm in incognito mode. Why am I in incognito mode? Hold on, I have to get my binary ninja password. Okay, here's Vault. I love these little pwnable binaries, right? It's so often you go and end up reversing some giant monstrosity like a fucking virtual machine that some asshole wrote. But when you open it up and it's just a tiny virtual machine, it's great. Or tiny, not virtual machine, tiny challenge that you can just look at. And it's like, this is what you get. There was a challenge in OCTF that was like, I don't know, it had a total of 7 bytes in the text section. And it had a very cool bug that you had to exploit. All right. So here's what it does, right? You can see it says, send me your payload. And then it calls a read, a strlen, and then something else. To get a high-level idea, it's good to do this. You can do the... No one's telling me that they can't see my screen? Oh, yeah. Okay. Hold on. It's OBS went crazy. There. I don't know why OBS went crazy. All right, please. So if you can't see my screen and I'm talking about stuff, holler into my ear on Zoom. Okay, cool. So this is the thing. First, it does this malloc, right? Well, first it asks us for our payload size and scanfs it into this variable, and then mallocs this. So this is the payload size. So this looks legit, right? It asks us for the payload size, it mallocs the payload size, and then later it'll read that same payload size. No overflow on the heap because that's a different module, okay? Here, it makes sure that malloc returns a non-zero, and you can see this is actually named temp input. Awesome, so here's our temp input. Okay, so if temp input is 0, it fails, so obviously it'll be non-zero. Then it tells us send our payload, and it reads the payload. And it reads the payload to temp input of the payload size. And this is the return address of read, so this is the amount that was read. Okay? So far, so good. Then it checks the length and makes sure that it's less than 6B. 6B is the size of our buffer in this case. 108 bytes for this testing one. Of course, we can determine that back in the graph view by looking at the assembly. So eventually, actually, hold on. I got a little ahead of myself. If the string length is less than 6B, if it's not less than 6B, it'll assert out. If it's less than 6B, it'll mem copy to this var10, which looks to be a pointer to var A8. So this is a pointer to buffer, and this is buffer. Okay, and mem copy, of course, takes a pointer, another pointer, and then the amount that was read. Okay, so it makes sure the string length is less than this, and then it copies it. So let's go look at that mem copy. Here's the mem copy. Okay, we call this mem copy with this pointer to buffer. Let's go look at pointer to buffer. So here's pointer to buffer. It's at RBP minus hex 8. And we get the address of buffer, which is minus A0. So the next thing after A0, what are all of these variables that it detects? Binary Ninja misdetected a bunch of stack variables. But basically, we start from A0, and then we write up to 6B. So this is small enough not to overflow. There's probably some other variables here and some padding and so forth. And then that's it, right? So at first glance, this looks perfectly secure, right? But obviously, this challenge has solves. In fact, this challenge has over 100 solves. So it's definitely very exploitable. Oftentimes in these situations, you have to sit back and say, okay, what are the possible vulnerability vectors, right? Possible vulnerability vectors is the buffer is too small. The buffer is smaller than 6B, but we just looked and that's impossible, right? So we eliminate that. We're Sherlock Holmes here, eliminating the impossible. So what's so there's enough space on the stack for 6B. What's another possible security vulnerability vector? The malloc was too small, but we looked at that. The malloc is correct. It reads in the exact amount. It's not too small. So we eliminate that as impossible. We say when we mem copy here, we'll overflow the stack because this is somehow bigger than the stack buffer size. But at first glance, it looks like we check it here, right? But are we checking it? Because this says amount read. Amount read is never checked. What is checked is the strlen of temp input. So it seems improbable that they'll be different, but kind of in a Sherlock way, Sherlock Holmes sort of way, once you eliminate the impossible, whatever remains is probably the vulnerability. Pretty sure he said that once. So let's take a look at how this could be different from this. Right? Let's take a look on my terminal. And actually, I'm going to take a look in IPython. IPython has an awesome module OS, and here you can just do system calls. So it's Pythonified. Actually, let's not do that. We'll just do, you know, confusion.c to look at the source of confusion. We have a buffer, and let's read into the buffer from standard input, 128 bytes. And then we will printf amount read. Okay. And then we'll printf strlen. Okay. And we put some new lines. Okay, we put in a new line, amount read 5, strlen 6. That's probably because I have some uninitialized data here. That's a preview for another challenge. All right, so we initialize that properly. Okay, amount read 5, strlen 5. Okay, so then we try to do something, a lot of data. And it's only going to read 128 of these bytes, but you'll give it a good boom. So it read 128, and strlen was 128. So when in doubt, try random shit. Why not? I mean, of course, we should sit down and think about it, but we could also try random stuff. What did I just leak? Someone saying clip it. What was just leaked? I don't think I leaked anything. Anyways. Okay. So, how do you get some random data? There's a couple of ways. One, Bash has a special character named random that every time is something random. But that's not so useful because, you know, it's just random bytes. Of course, the number might be a different length, but you know, no good. There's also an awesome device in Linux. There's a /dev file system, quick Linux lessons. Everything in Linux is a file. You interact with almost everything in the file system by opening a file, almost everything in the system by opening a file and talking to it. Now, if that file is, you know, your password file or the flag file, of course, that makes sense that it's a file. But that file can also be your sound or video card. So dev DSP is how the world has changed. In my time, in ancient times, dev DSP was my sound card. If you're also living in the Stone Ages and have a CD-ROM, dev CD-ROM, you can, if I do cat dev CD-ROM, it'll actually stream data from my CD drive. There's a workstation happens to have a DVD drive. I don't have a DVD in there right now. And so on. One of the things here is a pseudo device named dev random. This will print out randomness, but like true randomness from an entropy pool, etc. We're not going to go into that. urandom is a pseudo random number generator. I can pipe this through HD, and here's like a bunch of random data. All right. So when in doubt, why don't we try some random data at this confusion? Right away, we see something interesting. Strlen is much, much smaller than amount read. Here it wasn't. Here it is again. So let's do this. We can do instead of catting out dev random, which would have never terminated if it wasn't for this confusion guy. Well, actually, we might as well. I'll do this. All right, we use the T. T is a utility that'll take standard input, write it to a file, and then also write it to standard output. So we'll do T random stuff. All right, confusion. No good, no good, no good, good. Okay, what is at offset 69? What's 69 in hex? Hexadecimal 45. So if we hex dump random stuff and go to, well, this dumped a lot, and go to hexadecimal 45, 40, 41, 42, 43, 44, 45. It's a null byte. So why does the null byte mess this up? It's in my lectures. Null is a special character for string operations. It means this is the end of the string. Strlen doesn't check how much data is there. That's a nonsensical question when you're talking on the binary level. The data that was returned from read or what read did was write data into a buffer that already had some data in it anyways, right? Nothing magical happened to create a new buffer or anything like that, right? So what Strlen does is it goes through it has no concept of what data was there, what data you just read in. It actually has very little to do with this read. What Strlen does is it goes through the same buffer and it looks for the first null byte and it returns its index, and that is the length of the string. And so if we SH back in, okay, good. So if we SH back in and we echo, let's say 1000, then a new line, and then we give it a null byte, it'll immediately see the null byte. Strlen returns 0, and then the mem copy happens with the original size, right? So let's take a quick look actually before we do this. So we're going to read in one null byte at the very beginning of the buffer and then a bunch of data. We overflow this, or we don't overflow things here because we're reading it onto this to the heap into an allocation that is properly sized for us. Then we do this Strlen. Strlen sees that null byte, returns 0. Could have a null byte a little later as well, just as long as it's earlier than 6b. Then we do the mem copy with a pointer to the buffer, to the real buffer. And we copy it from the fake buffer, from the heap buffer. And we copy the full amount, not the string length, not the amount to the first null byte, which is what we actually checked for. We copy the full amount that we read, and boom. So let's take a look. Why didn't this crash? All right, Connor, what version of Ubuntu are these guys? Oh, interesting. So Bash supports null bytes and environment variables now, right? Yeah, but not in arguments. Oh, obviously, No. No. What am I saying? I'm saying stupid stuff, guys. Ignore me. Of course it doesn't support. How? Okay. But I did get it. Had some work on. Let's just use Spawn Tools. Or just Python. So we're going to print our 1000, a new line, a null byte, and then 1000 A's. Okay. Boom. That's frustrating. Okay, here we are. Look good. Boom, a null byte, and now we're going to pipe it into the challenge. Segfault. All A's. We are golden. From here, we've overflowed the buffer. There's no canary. You're home free. You just got to redirect execution. Okay. You can't hear me? Okay. All right, good. Awesome. All right, did that help with level 8? So that is the part of level 8 that is different than prior levels. By the way, I keep saying this is the part that's different, and I do that by looking at it and so forth. But you can do this semi-programmatically, right? So let's grab level 8. Connor, what is the challenge that is closest to level 8? Let's take a look at level 8 testing one. Actually, download this. And then Connor will tell me which one is the closest. Okay. But what I'm gonna do is dump out baby mem level 8. Should this probably will fail horrifically, but we'll give it a try. Actually, so here's the vuln, just the vuln function. This might work better. And no, because all the offsets will be different. Never mind. I might make another video for a poor man's diff of two programs. Yeah, is there a good open source binary diff tool? That's kind of missing. Maybe there is for Ghidra. Yeah. Huh. Ghidra extension uses bin diff. Anyways, I will look into what there is in terms of free binary diff things, but if you disassemble let's say level 8 testing, and we go and get level 7 testing. So this is what I just did here. We get level 7 testing. And you won't be able to see this. Level 7 and level 8. Okay, now we need some. So we disassemble it, right? Obviously, all of these offsets will differ because there's more code or less code. So we can use sed to search for everything up to a colon and remove it. All right, this looks better. Now this is level 7. We do the same for level 8. Okay, and now we can diff. Diff is bad for this. There's a utility called meld. Okay, I'm just going to YOLO this. Level 8. Yes, okay. So let me see if I can share this screen in a reasonable way. All right, this is going to look. Where's the meldius? Here we go. This is a diff of the two assembly files, right? And so you can see there are some things that are similar, but there are other things that are a little different. And you can align. So here is where it calls fd open, and sure, this offset is different, but that's because the binary is slightly differently laid out. But then you can see this highlighted stuff that's very different. This is the added part of this challenge that you can look at. So if you have two challenges that are very close to each other, or you have two binaries that are very large but have very few actual significant differences, something like this can help. There are better tools to do it that unfortunately mostly are not free. But if we can figure out a good free solution, we'll put up a quick tutorial on that. Okay, awesome. Well, that wasn't too bad in terms of changing out what I'm sharing right away. All right, let's see. Let's do this. Let's take a 10-minute break right now. My wife insists that I give everyone a break. And then when I come back, we will dive into what will be known as Toddler 1. Connor, are we ready to launch? We'll launch when I come back. Okay, cool. At the end of the break, 5:45 Arizona time, we will launch Toddler. Toddler 1, the first Toddler set of challenges. Awesome. See you soon. Do I have something? Maybe I should have a matrix. Yeah, I'll have a matrix. Wait. I think I already have the matrix. One sec. I'm going to spend half of the break trying to build a matrix thing in OBS. Yes. Oops. Okay, be amazed. Hello, hackers. All right, let's resume. Wait, sorry, everyone on Zoom, if you were just speaking to me, I couldn't hear you. Awesome. Okay. We're back. Connor, are we ready to launch? Right, I guess we have technically 1 minute left. Let's give it a. I guess start typing. Okay, so there's a question. How many challenges will be launched this week? That's an excellent question. We are starting with 7, and there will be an end less than or equal to 10. So we're going to launch, actually probably less than or equal to 9. We're going to launch 2 more tomorrow. It's the things that are launching tomorrow is the JIT challenges, because I just need some extra time to debug something. Basically, what I'm building for you for the JIT spray is Yan 8564. It's going to be awesome. All right, we are up. Let's roll. If you refresh, oh, I should have been opening the collaboration. If you refresh, the first 7 levels of Toddler 1 are up. Let me go on here and unlock the collaboration rooms. Okay, send messages. Connect, speak, video. Connor reports that we have a bug. What's up, Connor? Oh shit! I thought we got it working. Okay, so we have a quick cutting edge bug that is making level 1 harder than it should be. That's only level 1, right, Connor? Yeah. So let me show you what's going on with level 1. Collaboration room is up, by the way. Let's make sure that people are streaming in. Yes, people are in. Very few people. Go, go, go. This is going to be quite a thing. Yeah, I think that's a good idea. Okay. YOLO. Okay, trying to figure out what M9 Havoc means by the name badges. Oh, this! Yes. Yeah, these are my this is very little. This is just what I've accumulated that I haven't combined with my other badge tree yet. But I have like academic badges, various government program meetings, DEF CON badges, HitCon, a lot of good stuff. All right, anyways. Let's take a quick look at... Oh, what's the coolest badge I got? What is the coolest badge I got? I'm a big fan of this badge. I mean, I'd have to look at my bigger badge tree. I'm not so good at DEF CON always has really good badges. Ah, this is Cactus Con actually, not DEF CON. Yeah, these contest badges have a special place in my heart because they're basically a reward for almost dying hosting DEF CON. Okay, let's take a quick look at level 1 teaching 1. I'll explain what it's doing, and then you can go through there. Yeah. Well, I don't even have to use setarch. I just run it, and then it'll work on my computer. Okay. 1 sec. Let me get a Discord invite for somebody here real quick. Lol. Oh, so Connor, Toddler 1 will just crash automatically? I see. Yeah. So level 1 is unstable, but we're fixing it on the fly. Okay, so I'm downloading level 1 teaching 1. In fact, or Toddler 1 level 1 teaching 1. I have already downloaded it, so let's. All right, it's super easy. You run it. Asks you the payload size. Look familiar? Asks you your payload. And segfaults. All right, looks super familiar so far. Connor, there's a student that pinged you about a Discord invite. If you could get them the Discord invite, I think they would appreciate that. But fix this and then get them the Discord invite. Okay, so let's see what happens, right? We overflowed everything, so if you think back to the memory errors module, great. Let's redirect to the win function and be done with it. But it's not that simple. If we pull up the challenge in Binary Ninja, and we go to Vuln. Okay, this looks familiar, right? This is the testing crap, and then blah, you sent data and so forth. But here's a big problem. There is no win function. Win function's gone. Nothing in here is going to open, read, and write the flag for you. So now what? How are you going to solve this? Well, recall the shellcode module. The shellcode module said, hey, you can inject code into processes and have that code be executed. And if you look at the results of checksec, it says, hey, NX is disabled. If you recall the NX, the data execution prevention lecture, this means that you can write shellcode to the stack, jump there, and execute it. One more thing, if we run this multiple times, those addresses always stay the same. This challenge disables ASLR on itself. How does it do this? This is insane. Connor figured out some crazy way. Basically, as a constructor, when it starts up, it goes here to disable ASLR. Let's decompile that. Some crazy stuff. It basically, uses this personality syscall to disable ASLR, etc., etc. This is what more or less what GDB tries to do, but this works the way Connor wrote it, even for setuid programs. So even the setuid program will have ASLR disabled for level 1. This is what's currently crashing. This means that in the stack will be at the same location, and that means that you know where your shellcode is, and that means that you can jump there very easily. Awesome. Yeah, so right now level 1 is only going to work locally, it's only going to work locally, not even with sudo. Level 2 has ASLR on. Also 0 solves. I think this is the longest that level 1 is got. Well, obviously level 1 is broken, so yeah. No solves yet. Level 7, no solves. Oh, level 7 is amazing. These challenges are going to be great. You're all going to have so much fun. Two is not broken. 2 works. Only level 1 is broken right now. Has anyone here ever played Dwarf Fortress? Dwarf Fortress has a good definition of fun that I think is very similar to the type of fun that you have while playing, while doing these challenges. My advisor has a cool definition of fun. He is fond of saying that there is type 1 fun and type 2 fun. And type 1 fun is the fun that you have while you're having it, right? While you're eating candy or something. It's immediately fun. This is type 2 fun. You look back at it and think, that was fun. But while you're going, it might be painful. All right, Connor reports breaking news. Level 1 works. So if you run this challenge, SSH in. Connor, is the server getting slammed? Is my computer frozen? Server's getting a little slammed. Bear with us. One of the problems with the pace of this course is that we have half an hour every week to do server maintenance. I think the next time we're down, we should reboot with many more cores. Any idea what's... Okay, so let's oops, it's toddler. Launch toddler 1. Note that the stack is now always the same. Toddler 1 doesn't have ASLR. What's the difference between toddler 1 and toddler 2? Let's take... Okay, sorry about that. So, toddler 1. We launch it every time. It's the same stack location. This is incredible. It's like it's 1999 and we're exploiting buffer overflows in Bind, which powers the world's DNS servers. which had a stack-based buffer overflow bug, I don't know, like every 3 weeks in the early 2000s. But now we launch level 2. Okay. And we SSH in. And we run it. And every time it's different. But it's okay. You are used to address space layout randomization from BabyMem. You can use the same techniques to tackle the location of your shellcode here. Also, if you notice, now we have a canary. All right, let's take a look at the collaborators. All right, we have, man, some rooms for the global people that have no one in it. What the heck? All right, we have some good collaboration going on. Looks like Torch and Sandwich. Sandwich is back. One person sitting in Flynn, one person sitting in Verge. All right. So question on Zoom. Can you explain how we know we have to use shellcode? Well, let's take a look. Let me turn on the lights. Okay. When we run checksec, whenever you approach a security, a binary from a security angle, it doesn't cost you much to run checksec right away, right? So you look at checksec on toddler 1, level 2, teaching 1, and you see, okay, has full rel row. We haven't talked about rel row, and we're not going to talk about rel row. Everything has full rel row, which is a protects against the class of vulnerabilities that are basically obsolete. It has a stack canary. It doesn't have NX. And it has segments that are readable, writable, and executable. What does this mean? This means that you can write code into memory and execute it. And that's how you know that you could use shellcode, if you can find a way to redirect control flow into memory that you have written shellcode into that is also executable. Let's actually take a look at how you would do the that for this challenge. Actually, let's do level 1. Let's do level 1 testing 1. Run it in practice mode. You know, it occurs to me that grapes are a very good. You could even in-person classes, you could bring in like some grapes and just give every student a grape. And it's like a good little snack. Unless people are allergic to grapes, I guess. I don't know if that's a thing. All right. Level 1 testing 1. Of course, outside of the teaching, testing, etc., there is no what's it called? Sorry, my mind went blank. There is no stack dump. So let's just get in here. Actually, what if we do this? Paste a bunch of stuff in here. Okay, seg fault. Can I enable cores? Did we get cores working, Connor? Core dumps? Okay. So, I'm going to show you how to use something called a core dump to make your life easier. This requires the file that you're exploiting not to be setuid, but that's okay. You can copy it away from here, or you can just, in practice mode, chmod it to 755. And now it is not setuid. Now, if I run it and I give it, and now it's seg faults, still no core. Maybe. Core dump. Okay, segmentation fault, core dump. Oops. There is a file named core. The core is an ELF core file. If you recall, ELF really is just a collection of segments that describe where data is in memory. A core file is a collection of segments that describe what and where data was in memory when the program crashed. And the awesome thing is that I can use GDB to resume. Why do I keep typing code instead of core? Exactly where the crash occurred. How cool is that? Right? So this is where the crash occurred. I can see what was the instruction. It was ret. What was the stack? It was a bunch of stuff. This is some printable stuff that I copy pasted randomly from my terminal. That, I guess, that was here. Okay, so this is a very powerful technique, and the awesome thing is that you can work with cores programmatically as well. So let me show you how to do that. Launch up IPython, import pwn. All good evenings begin with import pwn. Now we do pwn.process. Actually, let's write this in one script. Okay, so pwn.process. Why is the Twitch talking about surgery on grapes? Where is this happening? What's going on? Okay, anyways. That bite was too big. Pwn.process. All right. /toddler1. Then we write send line 1000. Let's not do 10,000. That's a lot. And then we will send a cyclic pattern. Of 8-byte chunks to overwrite the return address of 1000 things. And then let's make sure that we wait on it and make sure that it crashes with signal 11, which is a seg fault. Okay. Boom. So crash with signal 11. That's why it's negative. Made sure that that happened, and then we so now we should have a core dump. Let me remove the existing core dump to make sure that we have a new core dump. Boom. We have a core dump where it looks like part of the metadata was on the stack was overwritten with our cyclic pattern. All right. So anyways, now we have a core dump. So now we can do this really awesome thing and open up the core dump file using pwn tools. And this is where magic starts happening. So this is where we crashed. This is the value of RSP, the value of our IP, etc. Right? So you can do a lot of different stuff on this core dump. If you hit tab, there's just a lot of stuff. You can, for example, see, okay, what was the canary? Or was there a canary? I guess it should have a canary if it, let's see. What do I want to do? I want to get the stack pointer. Okay, that's cool. What else do I want to do? I want to get the memory. The memory contents at the stack pointer. Get c.stack. So these are what? How do I just query memory? Obviously, I don't use this as a regular. Okay. So we have c.stack from c.sp to c.sp plus 8. So the next 8 bytes on the stack was this. And now we want to find this in our cyclic pattern. And it's at position 104. So let's turn this into a big script. Boom. So this is our offset to our IP. Awesome. Okay, offset to our IP is now 104. So there's 104 things on the stack, and then there will be our the return address. All right. So, what does this mean? This means that we can launch another process, send 1,000 things, and now we send 1,000 A's, or sorry, 104 A's plus 8 B's. Okay? So we make sure that it crashed, and then we load the core dump, and we make sure that the contents of the stack where we're about to return, rather the saved return address is now a bunch of B's. Success! It's a bunch of B's. Okay? Or let's do an assert here. Amazing. All right, so now we can control it fully, but first let's put some shell code. At this point, you can write a lot of shell code by hand on your own. I think it is now acceptable to start relying more and more on pwn tools for shellcode generation. So pwn tools, if you set up the architecture correctly, this tells it we're on 64-bit x86, and here you do pwn dot assemble pwn.shellcraft dot read. Oh, come on. What is it? I see. This tab completion doesn't work. Read file / flag. Okay. Read the file to standard out. So this is Pwn Tools has a shellcraft module, so you don't have to write shellcode yourself. Much easier to write shellcode yourself, in my experience. Well, it's much easier to debug your own shellcode than to debug Pwn Tools shellcode, just as a pro tip. But you can give it a try, and it might work. All right. Sorry. Let's start a new section here. So we've made sure that our assumption was correct. So now we're going to, instead of all B's, we will redirect our execution to immediately. We put our shellcode immediately after the saved return address, and then we have the code jump immediately after the saved return address. We're going to do this. We pack c.sp plus 8. Okay. And now we can print p.readall. And if we're very lucky, that'll contain the stack. The flag. For one thing, because we removed sudo access, we have to make the flag world readable. We can do that because it's in practice mode. For another thing, obviously, something broke here. Send. Let's what if we do 112? It should crash at all A's, right? No, it terminated happily. Why did it just terminate happily? Okay, if we do this, it'll crash, right? Why is it terminating happily? Oh no, okay, here it crashed. But if you don't do p.wait, it'll miss that crash? Connor, do you see this? This is insane. Okay, so, yeah. No, I think I know what's going on. Okay, so it didn't work. Something is bad. Let's do this. Let's open our a file with our input. And instead of this send line, we're going to write this to the file, and then we're going to okay, and then we're going to GDB. So we have fresh core dump here. We're going to GDB toddler with this core dump. Oh, it still didn't crash. Okay, anyways. Here's our input file. This contains our A's and the shellcode produced by pwn.tools. All right. If we GDB toddler1 and we run the shellcode, it crashes somewhere here, right? But let's disassemble vuln, and we'll actually break right at this ret. Okay. Now we run it with this input. Okay, here's the breakpoint right before the ret instruction. Okay, this is going to demonstrate a common gotcha when shellcoding. This is where we are returning to. This is our current stack pointer. And why? This is more than 8 ON. Step. Yeah, this is way wrong. So already we screwed something up. Oh, because we're in GDB and the stack is different. No problem. We can do better than that. I mentioned a way to start up a program and have it wait for you. So if we do, let's make a screen session. Oh wait, but okay, let's kill this. Okay, let me make a screen session here and just SSH in. That way I can, okay, anyways. So, if we make a screen session, and let's get back into IPython. Here we are. All is good. If we make a FIFO, and then we run the program with the FIFO, all is good. Now the program is waiting. Now we can GDB toddler. Oops, I forgot to SSH in. Now we can GDB toddler. Okay. We can attach. Okay. This was. We can attach to this guy. What? Oh, oops. What? But toddler1 is running. What the hell? Oh. Yeah. Okay. No, this is all stupid. Let's just do this. Let's wait for input here before moving on, and then we will pwn.tools will launch the process. We'll check its PID. We'll attach to it from GDB, and then we'll go here. Or let's just use pwn.gdb.debug. Sorry, guys, that was a brain fart on my end. Okay, here we go. Pwn GDB debug, and then we'll send all of this, and then see what happens. What's going on? Could not find a terminal binary to use. Hold on. Nah, we're just going to do this on my machine, so I'm not dealing with Pro Tools. Okay. On my machine, so I have Toddler 1, Level 1, Teaching 1. God damn it. But I need my history. All right, we have a bit of a live meltdown here. Don't panic. It's going to be okay. Talk to myself. Copy that. Paste it here. Oops. God damn it. Why? Why would it do this? Nope. Okay, this will work. No, come on. Yes. Okay, thank you. Awesome. All right, so /toddler1 doesn't exist, but we can do ./toddler1. Ah, I was using testing one. Let's download that. Okay. Not marked as executable. Man, guys, being a hacker is hard. Okay. All right, finally. We created a, we launched our thing in GDB. And now when I hit enter here, it is going to send in the data. Let's info proc map. Disassemble the vuln function. Here it is. And let's break at this ret. Continue. And enter here. What's it waiting for? Cannot insert breakpoint 1. I know what's going on. Don't panic. All right. Remember how Connor disabled ASLR in a crazy way? Now it's fucking. Now it's hurting us, our feelings here. Okay. Oh, I see what it was waiting for. Okay. So let's run. Will it then not relaunch itself? That's right. Okay. All right. For debugging, we'll just do this. ASLR equals false. Of course, this might not work still if this binary set UID, but we copied it actually off of the whole container. So this is fine. All right. So now we disassemble vuln. We break here. Continue. All right, here we go. We're about to return. We're about to return to from 4F8 to 490. Same problem. Okay, let's get offsets from GDB in here. Okay, forget the GDB. That was a mistake. We're just gonna do pwn.process. Okay, we'll do the pwn.process and then we'll wait for my input. So that the input function in Python will just sit and wait for input. Okay, now here we're going to there's an awesome utility called pgrep, which just gives you the PID of something that matches this query. And here we can do GDB toddler1, level 1 testing 1 with the PID, and it'll automatically attach. Amazing. Okay, now You can disassemble vuln, break here, continue, hit enter, boom, here's the breakpoint. RSP goes from 478 to 490. We still have a problem. That's interesting. Am I doing anything different between the two? So where do we get our stack pointer? From the core dump of the previous one. We can do this because ASLR is off. Otherwise, it would be different. We'd have to leak it from the program. Okay, let's see what this thing thinks. Oh, why did it? What? Oh. Stack pointer to F7, F4D 488. But when we actually why are these? Okay, put this, connect here. Okay. No. So it thinks it's at 488, but it is not at 488. We forgot to break at ret. Here's the PID. Connect to this. Oh, it's at the same spot. So here we go. Continue. Enter. But it's at 7.8, not 8.8. But this is crazy. It's launching it the same way, right, Connor? It's got the, maybe it just has the wrong stack pointer. I'm running it with ASLR false here, but that shouldn't matter. The address is changing by hex 10. Okay, so we're experiencing an interesting situation where the stack is changing a little bit. But that's okay. Here's what we're going to do. We're going to deploy a knob sled. You remember in your shell coding, there was a shell code where we jumped partway into your shell code at random. And you had to create a sled of knobs so that if we jump into any of the no ops, all of them will execute in sequence, and then, or the rest of them will execute, and then your shell code will execute. We're going to do the same thing here. We're going to create a bunch of no ops, let's say 128 of them. And then here, instead of jumping directly into the next instruction, we'll just jump, I don't know, partway into that knob sled. Okay? And then let's just see if this works. And it did. There's the flag. Okay? So when in doubt, if you're jumping right before or partway into your shell code, and there's just something going on, of course, try to understand what's going on. But if you are streaming to the world and things are getting increasingly embarrassing, you can say, okay, screw this. We're just going to put an ops LED and we'll go. The other amazing suggestion that from Twitch is disable ASLR in the process that generates the core dumps so that it doesn't have to disable its own ASLR. Let's actually try that and see. Maybe something. It shouldn't change it. It shouldn't change anything, but it might. So let's. Okay, so here we are. Let's break at continue. All right. Yes, exactly, and then it works. All right. There was a question on Zoom. Thank you, Stone Dant, for that hint. But anyways, the NOPS LED, there's nothing embarrassing about using a NOPS LED every once in a while. All right. There's a question on Zoom. Would the return always be where you inject your code? So I guess the way I'm interpreting it here, I overrode the return address, and then right after that, I put my shellcode. This is a terrible idea, actually, because if your shellcode uses the stack, it's going to overwrite itself, right? If it pushes anything or pops. Your shellcode, you can get away because of send file most of the time without actually writing anything to memory anyways, right? Unless you want to exec something. But for leaking flags in this class, you're probably fine without needing to write memory. But I'm almost certain that the way that pwn.tools does this is reads the flag, is it first reads it to the stack and then writes it out. So it will likely, if I didn't have this NOPS LED here, it would have likely clobbered it. But as it was, it will instead clobber NOPS LED after I've already executed it. This is not what you want. What you usually want is to put your shellcode, let's say here. This is the neatest way to do it. Let's show you how that works. So say our shellcode is going to be this. So here normally we put shellcode. Let's get some precision by disabling ASLR in all cases from the get-go. Again, level 1 will disable ASLR in itself and restart itself. But you don't have to rely on it. Why do so? What is crashing? 24. Oh. There. Okay. So that still works. So now we have this shellcode. Now, let's actually put it up here. We know the offset to RIP. If we have this shellcode, and then we just left justify it to this offset, it'll put our shellcode and then a bunch of, let's say, more knobs or whatever, null bytes, all the way to our return address. And so now we can put this here and put it here. So now we have our shellcode there. Actually, let's add our NOPS LED here. Let's assert that the shellcode is the right length. Make bytes here. Can't concat stir 2 bytes. What is the stir that they're talking about? Is this really a string? Oh, oops. There we go. I was trying to assemble that. All right. Assertion error that it's equal. So there's probably just too many knobs. What the fuck? Okay. That shellcode is pretty big. All right, we don't have a lot of room for knobs. That's fine. So if we have our shellcode, we can put our shellcode here. Now our shellcode is in the core dump somewhere. We can actually determine where that is. So we can look at c.find, right? No, what? Memory find? Find stack. C dot stack dot. Can you guys, Connor, are you still here? Just in case I need. God damn it. Let me just, okay, good. No, I'm just checking. My headphones were making weird noises. Let me core. Okay, C dot stack dot find. Good. We can look for where our shellcode is in our core dump. Okay. And here we can see that it's not in there at all. We just sent it here. Oh, no. What the fuck? Why can't it find the shellcode? We sent it, waited, it crashed. Okay, that's fine. Instead, let's put we'll put a bunch of X's and then we'll find those X's. Oh, because it's by the time it crashes, it is before. Okay, perfect. I know what's going on. Okay, here we go. We start at c.sp minus OX100. Okay, I don't know what's going on. Here's our shellcode. And then where is it in? Why wouldn't this shellcode turn up in the core dump? This is just a couple of bytes in the shellcode that I'm looking at. It's in there. Ooh, that's ominous. Here it is. So is shellcode in this guy? No. It gets fucked up. So one risk with what I just did, where I put my shellcode into my into the stack frame, is that as the function does stuff between the overflow and the return, it'll corrupt your shellcode. So solutions to this have a very, very tiny shellcode. So there's less of it to corrupt, or do what we did before and put it after the stack frame, although that's not always viable. Or you might need to write shellcode that can jump around corrupted bits. So for example, in the middle of your shellcode, you put a jump and jump later. I'm going to take the route of writing a... Or, Connor mentions, if you're running your code locally, you can always also put your shellcode in your environment. So if you create shellcode up here, we don't have to let's justify it here. If we just take our shellcode here, okay, and we create an environment where we have a shellcode variable. That is our shellcode. That environment, when you run, recall that the environment gets put on the stack. So that shellcode will all be on the stack. You can pass it everywhere because, of course, that shifts offset. So you want to be careful about that. Environment equals shellcode. Environment equals shellcode. Environment equals shellcode. All right. And now here, we'll be able to find our shellcode on the stack, and we don't need to send it here. We can just send our usual stuff. What? Environment keys must be strings. Oops, env equals shellcode, env equals env. And this overrides the environment variable with which you are launching stuff. And everything is not good. Oh, it's not supposed to be? No, this is something else. This is in sending the cyclic pattern. Oh, probably there's not enough. Let's try that. Send less data. Yeah, awesome. Okay. Now we don't need this assertion. Boom. Okay, so where's the shellcode? We have a shellcode address. We know what the stack pointer at the return is, but that doesn't matter because what we are overriding this with now is the shellcode address. And here is our flag. Cool. So what we did, to summarize, created some shellcode using pwn tools, put it in a environment dictionary that we passed in when we launch the process. So we set that environment. The environment goes on the stack. That means our shellcode is on the stack. Since the stack is executable here, we're good to go. We send a 256-byte cyclic pattern to see in the core dump where we crash, right? Then we send, actually, let's simplify this a little bit. We can see in the core dump where we crash, and we can get the shellcode address from here. Boom, perfect. So we see in the core dump where we crash. We get the offset to the return address. We also find where our shellcode is in memory. We print out both, and then we do the exploit, which sends the padding to overload the buffer, and then the address of our shellcode. And our shellcode is already on the stack because we passed it in as in the environment. This, yes, now this will still work because it no longer depends on the exact positioning of the stack at function invocation. Cool. So this is ASLR off level 1, teaching 1. I'm sorry that we took so many dead ends. I wanted to show little tidbits that ended up being tar pits. Now, ASLR is off. What if ASLR was on? Of course, you would have to leak out ASLR somehow, or figure out how to partially redirect execution, although that's unlikely to work because your shellcode is on the stack and the execution generally sticks to the main binary in the libraries. So a partial address override won't redirect you to the stack. But you'll have to either leak it out in level 2 or do something. Well, you'll have to leak it out. And you're used to that. You've done this in BabyMem in the previous module. Cool. Let's check in on wow, everyone moved to Team Verge. Team Verge is going crazy. Cool. All right, people are working through it. Let's see. People on the collaboration are discovering that the shellcode created by Pwn tools is not optimal. 14 solves on level 1 and only 2 solves on level 1 testing. And no solves otherwise. Oh dear. So, to stress that these challenges will require you to put together the concepts learned in multiple modules. So level 1 is memory errors plus shellcoding. Level 2 is memory errors plus shellcoding. Level 3, Connor's basically, memory errors plus shellcoding plus sandboxing. Right? Level 4 is going to be reversing plus memory errors plus shellcoding. Level 5 is going to be reversing plus memory errors plus shellcoding. Level 6 is shellcoding and reversing and memory errors. And level 7 is just shellcoding and reversing. Super fun. That's right. Yeah. I guess there's a bit of a jailbreaking throughout the whole. That basically it's a combination. It's scenarios of exploitation. So Connor, maybe based on this start, maybe you're right. So just to catch everyone up, Connor has been urging fewer levels for this module. He's been looking out for you all. Maybe we'll do less than 10. But I have so many other ideas. No, we'll definitely have more than 7. The JIT spray is not up. We have at least 8. Alright, let's see how people are doing. Oh my god. There's someone on Discord just pinged me saying, hey, I have a question. And then they're asking me, I figured, okay, it's from the collaboration group. They're you know, they have a question about something. And then they're asking me right now a question about a network challenge. Apparently it's for our CSE 365. Yeah, Fish and Jed are teaching it. ASU has way too many cybersecurity courses. You should just pwn.college. Yeah. Imagine if the whole undergrad CS curriculum, just pwn.college, all the way through. The opinion on Twitch seems to be that ASU doesn't have enough cybersecurity courses. All right, usually we are answering questions to the bitter end. People seem to be deep in thought. This meme is definitely going in the meme review next week. The big question for us now, Connor, is do we make everything after this toddler, or do we go back to baby for the individual concepts? Gotta go back to baby. So Connor and I have been talking about making a freshman level edition of Pwn College, starting from the very, very basics. And the question that just came up was, what do we name the challenges? It might have to be like Fetus 1, Fetus C, But that just sounds weird. We might have to graduate everything to toddler here, and then the toddler one will be like, I don't know, young adult one or something. Well, the analogy is falling apart. Yeah, another last Joel one. Oh my god. Oh, there's a baby to infant to toddler. Yeah, but an infant's a type of baby, isn't it? Isn't baby like the category that includes infants and toddlers? Yeah. Yeah, we could do that. Infant, baby, toddler. Yeah, we should do the freshman course, and then, like you said, there's another idea for a follow-up to pwn.college, where we just like pick a real-world target, and over the course of a semester, find the bug and exploit the bugs in the real-world target. I think that would be pretty cool. Yeah, awesome. Everyone is hard at work. It still worries me that the amount of collaborators on the collab hours have kind of dropped in the last two modules. But people are surviving. I mean, the average grade of the course actually went up this week. Yeah. I think the Countermaster on Twitch is asking if I have any experience in breaking DRM for academic reasons. I actually have extensive experience breaking DRM specifically for academic reasons. Let's see. How can I copy paste this? Here we go. How do you add? Do you add people in? Oh yeah, you do. Wow, this is just like IRC. Did my microphone just pick up Brooke talking to the baby? I think it did. Yeah. I think that was Mrs. Yon. Yeah, so the awesome thing about that paper I just linked for breaking DRM, basically that paper had an enormous amount of reverse engineering, a lot of this sort of dynamic, not kind of shellcode injection. We basically injected a lot of logic into applications to monitor the flow of data between buffers to identify when data was decrypted in memory. And it also had VM reversing, because one of those programs, Spotify, used a virtual machine based anti-debugging measure. Someone's asking me to read Georgian on the Twitch. I don't read Georgian, unfortunately. Everyone is shockingly upset that the challenge starts with a T instead of a B now. Yeah. Embryo. Embryo is not a bad. Embryo is it might be a good name for the baby challenges. Cause that's yeah, that's good. It's much less awkward sounding than fetus. Embryo. Yeah. Maybe that was the remaining hurdle to creating 194, but that'll be such a huge amount of work. I'm teaching ASU 101 this year. So ASU has a course to introduce incoming freshmen to college, right? Basically, what is college, what is being on your own like, what is, etc. And I am teaching several sections of it, and I'm trying to make it also useful technically. So we're in ASU 101, we're going through the Bandit series of war games challenges, right? Which is basically like how to use Linux, starting from how to cat a file. And it is shocking. Like it's very easy to take what you know for granted, right? Like I know how to CD and how to cat and so forth, but having to explain that from first principles to incoming freshmen is really hard. I think that our freshman year pwn.college thing is going to be something very similar. Someone was saying, someone's asking, isn't ASU 101 taught by TAs? I think it maybe used to be. They try as hard as possible to get enough professors to teach it. It's much more, because part of it is also about getting the students comfortable with professors and interacting with professors. Opinion on Twitch that the freshman pwn.college course needs to be sophomore. No, absolutely not, man. The whole point is get started right away. Imagine if instead of wasting time on Java, boom, x86 assembly. Because at the end of the day, x86 assembly, if you learn it first, is simpler than Java. There are 7 variables or whatever, right? RAX, RBX, RCX, RDX. Done. There's actually less boilerplate. It's just underscore start, colon, and then your code. Much easier. Yeah, that would be interesting. Connor is saying in my ear that a module focusing on C++ reverse engineering would be interesting. It would be. The problem is the step-by-step challenges, right? So we would, level 1 would be just a simple C++ class. Level 2 would be, it might work as a combo module, reversing and then memory errors in C++. That could be cool. But given the various research projects that we've been running lately, I'm looking at the Twitch chat, someone saying there are kids out there that are writing exploits for Chrome. Absolutely. And actually Chrome and Acrobat, specifically Acrobat is so amazingly vulnerable, right? We could definitely have a follow-up to pwn.college for second semester seniors or whatever, where it's an independent study group type activity, and I'm positive that we could find real bugs in Acrobat and get Adobe to fix them. There are 400 level, I think there are 400 level topic courses. Yeah. The C++ reversing idea is not very popular on Twitch. Connor, just FYI. One cybersecurity class per semester. That I can see how that would be good, but man, if I lose another semester of sleep, Steve Jobs will murder me. Steve Jobs talks to me through my Apple Watch. Other than telling me to wash my hands several times a day, he's telling me that I'm dying of sleep deprivation. All right, we have 6 minutes in the course. I guess everyone is busy. Verge is the last surviving collaboration room. Everyone is busy collaborating. Still no solves on level 2? Why? Man. Maybe we made these too hard. Maybe you should have had a level 1.5, Connor. So Connor's pointing out that my original plan for this module had no level 1. Level 2 was going to be level 1. Connor actually went insane into, like, if you look at that disable ASLR function, it's insane. I still am like 90% of the way to understanding it, but Connor spent like hours on that thing, and then when I said no, we don't need it, he refused because he spent so much time on it that he made it into a level without ASLR for you. So yeah, man, only 2 solves on level 1 testing 1. No, but I just walked through level 1 testing 1 just like a second ago. So if you understand that solution, you got this. How do you dump that core file on the server? 2 things. Let me just walk through it. Maybe it might make a good clip if it's fast enough. Here we go. I'm SSHing into pwn.college. All right. I have my... actually, hold on. This one is already disabled. I'm launching up level 1, teaching 1 in practice mode. SSHing into the server. Look at toddler 1, teaching 1. It has a setUID. A setUID binary will never dump a core. So if you chmod -s to remove that setUID, it's gone. Now this will dump a core. The only remaining problem is, one, I need to be in a directory where I can write to, which is my home directory, so that's fine. But when you first SSH, you're in /, which is not fine. And then you need to set your limits to have an unlimited core file size, and then you're good to go. So remove any existing core, run toddler 1, payload size 1000, and we just put in a bunch of stuff to overflow the buffer. Okay, overflow the buffer. We sec faulted. I put it, and it says core dumped. Put in too much stuff, but that's fine. And here is the core. Core dump is here. We GDB toddler core, and now we can look around in the core. That's the string that I pasted in like crazy. Okay, does that help? Wait, where did I see this? Oh yeah, that was on the Twitch. Cool. Someone on Twitch saying this is midterm week. I thought last week was midterm week. Oh, I see. So there is no midterm week. It's basically whenever it's it's a distribution that centers on between this week and last week. No, but this module, okay, you're having some slow progress starting it, but that's fine. We'll get it. I believe in you all. You've made it this far. You have all the concepts. You've done all of this in pieces. Now it's just time to put it together. Whoa, what do you mean multiple midterms? Oh, I see you. I don't understand tests. Screw tests. No tests. CTF only. Comment on Twitch. Everything onwards level 4 is Yan 85 FML. It's Yan 85, man. The only tests are the testing levels. Those are good. I remember when we invented teaching levels. That was insane. The whole class was failing. We had like a 90% fail rate. They're like, testing levels, and boom. Beautiful, beautiful passing curve. Oh, someone saw level 2. Level 2 teaching 1 has been solved. Oh, great job, Zero. First blood. First blood. On level 2. Awesome. That's still testing. Yeah, exactly. That's still level 2 testing 1. Technically, you could solve that by leaking out by reading the stack dump, but you can do this. That's like, or how about this? That looks like a cannon, but it's a whistle. That meant to be a. All right, my audio cues could use some work. Okay, we're at the end of class. If someone has something else, speak now. Otherwise, good luck on this. So, collaboration rooms remain open the whole week. Please take advantage of this. This is a hard module. And your fellow students are also pushing very hard. Jump into collaboration and collaborate away. Sorry, I was catching up on Twitch. A lot of these concepts are tricky, but once you get the concept, the execution is just making bits line up. You can do this. You have done the memory exploitation in Baby Mem. You have done the shell coding in Baby Shell. You've done the jailbreaking in Baby Jail. Just put it together. And you've done the reversing in Baby Rev. Again, Yan85 now has YouTube walkthroughs. Go to my the pwn.college YouTube channel and take advantage of those walkthroughs. Look at the 1.5 hour walkthrough by FreakMod, who has a kind of looking back at how he solved it, and then one of my graduate students, never having seen it before, just started the webcam and went for it. So that one has timestamps where if you just want to skip through the very relevant points, you can. All right. Let's get this. As a reminder, Connor's office hours are Friday at 2 p.m. My office hours are Monday at 3 p.m. Collaboration room is open. There's also help. Probably we won't monitor closely the individual collaboration text chats, but if you want to ping us from help, go ahead and ping us, or write in help. We monitor that pretty closely. Keep the memes rolling. We've got already have some materials for the meme review. It's going to be pretty cool. Awesome. Good luck. And I will see you on Monday. I feel like I should say something else encouraging because... Maybe something like... The program has its internal state. And it has internal thoughts. And it has its hopes and dreams, right? And its hopes and dreams don't include the flag in any way, shape, or form. Not one of these challenges opens the flag file by design, right? But it's up to you to change its mind, to mind meld with it perfectly so that your thoughts and your hopes and your dreams become its code. And when you achieve this perfect synergy, you will get the flag. I believe in you. Good luck.